Hello everyone, my name is Miniseti. I hope you all are staying healthy. Today we are going to talk about theory of production, especially for CA Foundation. First of all, we will see Cobb Douglas production function. Cobb Douglas production function is given by Paul Douglas and mathematician Charles Cobb. We can represent this production function by two ways. First is L to the power alpha and K to the power beta. Second way to represent this production function, L to the power alpha and K to the power 1 minus alpha. Meaning of these both is same. How meaning is same we will also discuss, but first of all see Q is equal to output, L is equal to labor, K is equal to capital, alpha is equal to output elasticity of labor. That means how much output change when we change labor. Beta is output elasticity of capital. That means how much output change when we change capital. A is the all factor productivity, or we can say that A is total factor productivity, which is constant and mainly depend on technology. And this production function mainly tells us the technical relationship between amount of output and amount of two factor of production, labor and capital. Most important property of Cobb Douglas production function is this production function is linear homogeneous production function. Cobb Douglas production function is a linear homogeneous production function. What do you mean by linear homogeneous production function? Linear homogeneous production function means we are receiving constant return to scale. Constant return to scale means change in output same as you change in input. For example, if you double your input like labor and capital, your output will also double. That means you are receiving constant return to scale. But how we can know we are receiving constant return to scale? With the value of alpha and beta, we can know we are receiving constant return to scale. If alpha plus beta is equal to 1, that means we are receiving constant return to scale. Suppose alpha is equal to 3 over 4 and beta is equal to 1 over 4. When we add all these two values, it will become equal to 1. That means we are receiving constant return to scale. But if alpha plus beta is more than 1, that means we are receiving increasing return to scale. If alpha plus beta is less than 1, that means we are receiving decreasing return to scale. But in Cobb Douglas production function, alpha plus beta should be equal to 1 because Cobb Douglas production function is linear homogeneous production function. Linear homogeneous production function means we are receiving constant return to scale. In some book, you will see Cobb Douglas production function like this. But in some book, you will see Cobb Douglas production function like this. Don't be confused. Meaning of both are same. But how? As we know, Cobb Douglas production function is based on constant return to scale. And in case of constant return to scale, alpha plus beta is equal to 1. If we bring alpha in this side, then beta become equal to 1 minus alpha. So, in place of beta, we can write 1 minus alpha. So, by this way, both functions are same. So, don't be confused. Now, we are going to talk about law of variable proportion. This is short time period law. And during short time period, we cannot change our fixed factor like land because we don't have enough time. But we can change our variable factor labor. According to this law, as more and more unit of labor combined with the fixed factor land, then initially marginal product of labor increase. But why initially marginal product of labor increase? Because of proper utilization of fixed factor land. But after certain time period, marginal product of labor start declining, eventually become zero. But why marginal product of labor start declining and become zero? Because of overutilization of fixed factor land. We will understand this law with the help of small example. I have small piece of land. My land is fixed. I cannot change my land, but I can change my variable factor labor. Initially, my land have capacity to absorb labor. That's why initially as I am hiring labor, I am receiving more return on labor. That means marginal product of labor is increasing. But after some time period, my land don't have capacity to absorb more labor. But still I am hiring more and more labor. Obviously my return on labor will reduce. That means marginal product of labor will reduce, eventually become zero or negative. First column we have labor. This is total product, average product and marginal product. This law divided into three stages: increasing return to variable factor, decreasing return to variable factor and negative return to variable factor. Increasing return to variable factor means I am receiving more return on my labor. Marginal product of labor is increasing because of proper utilization of fixed factor land. Here you can see marginal product of labor is continuous increasing. At 3 unit of labor, marginal product of labor become maximum. Even you can see initially marginal product of labor increasing more than average product of labor. But after some time period, means end of first stage, marginal product reduce and become equal to average product. Decreasing return to variable factor, that means return on labor reduce, marginal product of labor start reducing because of over utilization of fixed factor land. That's why my marginal product reduce and become zero. Even my average product also reduce and total product become maximum. Negative return to variable factor, that means too much utilization of fixed factor land. That's why my marginal product become negative and average product reduce so much. Now we will see a diagram. Here we have two panels, both are connected with each other. Or horizontal side we have labor. Vertical side, this side we have total product, this side we have average product and marginal product. This is total product, this is average product, this is marginal product. And this diagram divided into three stages: first, second, third. First stage means increasing return to variable factor, second means decreasing return to variable factor, third means negative return to variable factor. During first stage you can see total product is continuous increasing, marginal and average also increasing, even marginal increasing more than average. At E point, marginal product become maximum. At E1 point, at the end of first stage, marginal product become equal to average product. After that, our second stage start. During second stage, total product become maximum, but average product and marginal product start reducing. At the end of a second stage, marginal product becomes zero. Then our third stage start when we are receiving negative return to variable factor. During third stage, our total product reduce, average reduce, marginal become negative. Now we are going to talk about return to scale. Return to scale is long time period low. And during long time period, we have enough time, we can change all factor of production as per our requirement. That means during long time period, all factors are variable. There is no fixed factor. When we change scale of production by changing all factors of production, then three possibility can be arise: increasing return to scale, constant return to scale and diminishing return to scale. Increasing return to scale means percentage increase in output is more as compared to percentage increase in input. For example, percentage increase in input is 100%, but percentage increase in output is 120%. That means percentage increase in output is more as compared to percentage increase in input. Constant return to scale means percentage increase in output is same as percentage increase in input. For example, percentage increase in input is 100% and percentage increase in output also 100%. Diminishing return to scale means percentage increase in output is less as compared to percentage increase in input. For example, percentage increase in input is 100%, but percentage increase in output is only 80%. It will be called diminishing return to scale. As we earlier discussed in Cobb Douglas production function, if alpha plus beta is equal to 1, that means we are receiving constant return to scale. If alpha plus beta is more than 1, that means we are receiving increasing return to scale. If alpha plus beta is less than 1, that means we are receiving decreasing return to scale. Now we will see ISOQuant. ISOQuant shows a different combination of labor and capital which give us the same amount of output. ISOQuant shows different combination of labor and capital which give us same amount of output. First column we have combination, second column labor, third column capital, last column we have output. At combination A, we are using 1 labor and 12 capital and receiving output equal to 100. At B combination, we are using 2 labor and 8 capital and receiving 100 output. Similar, you can see other combination, but the most important thing is that whatever combination we use, we will receive same amount of output which is equal to 100. When we convert this table into diagram, we will receive this. On x-axis we have labor, y-axis we have capital, and this IQ is our ISOQuant curve, which is showing a different combination of labor and capital which are giving same amount of output. Now we will see ISOQost line. ISOQost line shows different combination of labor and capital which producer can buy at a given price of labor and capital and given amount of money. ISOQost line shows different combination of labor and capital which producer can buy at a given price of labor and capital and given amount of money. First column we have combination, second column we have capital, and price of per unit of capital is 30 and the price of per unit of labor is 10 and total expenditure is equal to 120. Total expenditure means money that producer have for doing expenditure on labor and capital. At A combination, producer is buying 4 unit of capital but 0 unit of labor, and price of per unit of capital is 30. 30 multiply with 4 equal to 120, means 120 comes within expenditure of producer. Similar, you can see at B combination, producer buying 3 unit of capital and 3 unit of labor. Price of per unit of capital is 30. 30 multiply with 3 is equal to 90, and price of per unit of labor is 10. 10 multiply with 3 is equal to 30. 90 plus 30 is equal to 120. Similar, you can check other combination. Whatever combination producer will buy, it will come within the expenditure of 120 because producer only have 120 rupees for doing expenditure on labor and capital. If we convert this table into diagram, we will receive this. On x-axis we have labor, on y-axis we have capital, and this line is our ISOQost line. You can see in this ISOQost line we have so many combination A, B, C, D and E which are showing whatever combination of labor and capital we will buy, it will comes under the money which we have for doing expenditure on labor and capital. Now we will see producer equilibrium, or we can say that least cost combination. We have already discussed about ISOQuant curve and ISOQost line. Producer equilibrium is a point where ISOQuant curve is tangent to ISOQost line. Producer equilibrium is a point where ISOQuant curve is tangent to ISOQost line. On x-axis we have labor and y-axis we have capital. This AB is our ISOQost line. IQ 1, 2, 3 are ISOQuant curve. At this E point, you can see ISOQuant curve is tangent to ISOQost line. That's why this E will be called producer equilibrium point. We cannot establish our producer equilibrium on P and K point because both these points lies in lower ISOQuant curve, and lower ISOQuant curve give us less amount of output. No doubt this ISOQuant is higher, give us a higher amount of output, but we cannot establish producer equilibrium at this ISOQuant because this is crossing budget of producer. This is ISOQost line which shows budget of producer, but this ISOQuant is very far away from budget of producer. That's why we cannot achieve this combination. E will be called producer equilibrium point. So this is all about theory of production. I think you got it, and thank you so much for watching this video. Bye, take care.